All right. It's time. It's time to get this show started. I'm hopefully hopefully everything's working correctly. Let's see who's in the chat. Hello everybody that's in the chat. Thank you for joining me today. I know it was kind of last minute. I just happened to check my channel and realized that it had been like 28 days since the last stream, and last stream I said that I wanted to do it monthly, and that's what I'm going to try and stick to. I think not overloading myself trying to do it like weekly or whatever I was doing before or trying to do before will help consistency, set realistic goals and try and stick with them. So today I got something a little different. We've done a lot of Hack the Box or Vuln Hubs or whatever. Today I'm going to do some challenges that I had written for BSides CTFs. Now, a couple notes on that. One is I wrote almost all of these myself. I got some help on the web challenges from my buddy Resnok, who you've probably seen in the channel once or twice. And he did several of the web challenges for me, which was great help as I was like trying to do a buzzer beater for BSides San Diego. The rest of them I wrote. Now, they're probably very similar to some of the other CTF challenges you've written. You know, when you're doing common exploitation, it's, you know, you're going to see common questions together. Another thing about these challenges is I'm in the middle of rewriting a new CTF engine to be used moving forward. I didn't write one explicitly for this year. I kind of just threw one together using CTFD, which was extremely easy to use and very easy to use for BSides San Diego, which was helpful. Once I got asked to do BSides Oklahoma, I realized that the automation involved in CTFD wasn't quite there. And there was another complication that I'll talk about in just a second. But I realized that CTFD wasn't really what I wanted if I was going to run more of these. And I had such a good time running the two events this year. I'm hoping that I'll get called back for both the events next year as well as some additional events. So I'm in the middle of writing that. I was planning on waiting to do this walkthrough until the alpha version of that engine was written, but it's taking longer than I thought. And frankly, I didn't really have a video lined up for today, so we're just doing this instead, which it'll still be fun. They're good challenges. I'll talk a little bit about how they were made, how they were deployed. I'll talk a little bit about the engine that I'm building, maybe towards the end of the stream. Short, not a tech preview because it's not really ready to be shown yet, but a preview of functionality, like design intentions and whatnot. Hey, F Society, it's good to see you. Thanks for joining me, everybody. I'm going to have a good stream today. So for this CTF, what I wanted to do, I wanted to make some basic-ish challenges. If you're familiar with my stream, you know that it's really important to me that we're not just entertaining the really obscure wizards out there that are looking for 7-bit bytes, like Middle Endian, assembly languages and stuff. Like, I want to build challenges that people can get into more or less from the ground up. Now, I made the mistake of saying that BSides Oklahoma was a noob-friendly CTF, and there were a few people in there that were like, I am a noob, and this is not friendly to me. This is not friendly enough to me, which made me realize that I haven't hit my mark yet. I haven't gotten super noob, or not super noob, but I haven't gotten noob-friendly enough. I need to build some, here's what to do if you don't know what you're doing kind of challenges. And but the challenges I have so far, I think, are if you're learning about what you should be doing, here's some good challenges to start off with. And then there's a little bit more complicated stuff. So we'll go through that. Another thing that you'll learn about me or may already know about me is I'm not a huge fan of crypto challenges, not because I have a lot to say about crypto challenges, but the big thing is that I'm not a crypto guy. And the people who are crypto people, I feel deserve some crypto challenges. And once I get my CTF engine written, I'll be able to devote time to learn skills enough to be able to write challenges for those skills. So my crypto challenges are kind of more puzzles than like real cryptanalysis. Oh my God, from Poland. Welcome, Pan. Thank you for coming from across the world. What time in Poland would be like 10 hours from now, right? Are you +2, +3? I'm not sure what time zone Poland's in, but like it's 1400 here. So it's got to be like midnight, 1 o'clock your time. But thank you so much for joining. That's awesome. But yeah, so crypto is not really there. I have some password cracking challenges, and I know a lot of people don't like password cracking challenges, and I agree with you. The reason that password cracking CTF challenges are generally frowned upon is because it often becomes a question of what word list did the challenge writer use. So in my password cracking challenges, they don't get too complex. Like I said, they're they're kind of noob friendly, but they give you the dictionary. They tell you which dictionary to use, and that dictionary is RockU. Just because it's easy, right? We're not here to make you learn about the different dictionaries. We're here to teach you password cracking methodologies and learning about hashes and stuff. So that's kind of the disclaimer. The rest of it's pretty standard. We've got some system challenges that are some Priv-esque stuff. We've got some scanning and recon challenges that kind of teach about enumeration and reconnaissance. And then we have some web challenges. No binary challenges. You know, if you're familiar with me, you know I'm not a binary exploitation person. I know a bit about it. I do have my GXPN. I have learned to ROP chain, but I don't feel, especially the immense time crunch I was in for BSides San Diego, I didn't feel that I had the expertise to just like bang out a bunch of binary exploitation challenges. Again, once I finish my CTF engine, then I will build more challenges that are a little bit more diverse than what you're seeing today. Anyways, today we have, let's see here. We have a few different challenges available to us. I wrote some, like I said, some password cracking and crypto, scanning, system challenges, and web challenges. And then I also built a more realistic, real world-ish kind of pen test box that you could think of as like a large hack the box. Maybe not a large hack the box, but a hack the box kind of a style challenge where there is a pivot. You actually pivot from one machine to another, one container to another, but you pivot from one machine to another, and do some kind of more real worldy stuff than just like regular CTF, like single challenge and done sort of things. You will see flags today. These flags were for BSides Oklahoma. They will not work in the future. I will likely reuse these challenges in the future, but they will join a pool of many, many, many challenges. So, you know, knowing the answer to these challenges won't necessarily like win you another CTF that I run, but it will give you a head start. So, okay, let's dive in. So I want to start with the crypto password cracking just because it's there. I'll probably finish up with the box challenge just because it's a little more in depth and we'll kind of build up to that. Oh, another stipulation right before I jump into the challenges. I QA'd these heavily for BSides San Diego back in February, I think is the correct timeline. January, February, somewhere in there. QA'd the ever living heck out of them. I ran through them, every one of them once, just to refresh myself how they're solved before BSides Oklahoma, which was July, I think. I don't actually remember. And I haven't solved them since then. So this is not going to be a real quick, like, here's the answer. I might even stumble on a few of these as I like relearn how to do it. That's fine. I think that's better even. I think it's better for everybody to kind of see the methodology involved. But I did create these, so I think it'll be abbreviated. But a few of these I might be like, what the hell was I thinking? And, you know, just is what it is. All right, let's do this. So password crypto. So these are the actual challenge descriptions. And the reason I'm showing these rather than just saying, okay, here's a hash and let's move on is because the titles and descriptions are hints for these things. So let's go ahead and we'll less the password crypto file. Another quick thing is that the panel, the tmux pane directly above where I'm going to have the challenges listed is where the camera is. And all that says is this is camera, this is camera, this is camera over and over and over again. So actually here, So like, that's why I'm not displaying that, just so that I don't put a window over, or put text or whatever underneath the camera. So, okay. So get cracking. So this is the first cracking challenge that we have. And it says one of our operatives has recovered a credential belonging to an anti-Goose League member. We need the plain text password so we can access their servers. See what you can do with this. Another quick note. This whole game was, BSides San Diego was video game themed. And so this whole game is Horrible Goose Game, or Untitled Goose Game themed. It branches into other bird related memes, but most of it's kind of this you are part of the Goose Rebellion sort of a theme. Okay, so we have a hash here, and the straight away thing to do, especially since this is like a 100-point challenge, like basically Crypto 101, is to just throw it in John, and it's very likely going to crack it out of the box. However, when we're doing password cracking, there's a few things that you can do to kind of give you a better shot at being right the first time out. And so hash ID, hash identifier, there's a bunch of these different utilities that you can use, but just throw this in there just to see what kind of a hash it is. So John will attempt to do some mostly decent guessing as to what hash format you're about to attack, but it doesn't hurt to have a second opinion, right? So hash ID is pretty sure that it's MD5. It could also be domain cache credentials, perhaps, but it's pretty sure it's MD5. So we'll go ahead and we'll make a file called hash. We'll put our hash in there. We're gonna John, and we're gonna set a word list, because if you see here, first of all, the flag here does not follow the flag format. I have a flag format for the majority of the challenges. Sometimes it doesn't make sense, like password cracking. So it doesn't follow the flag format. And all password cracking challenges will be solved with the RockU password list. All right, so we let you know what password list it is. So we're gonna word list equals user share word lists rocku.txt, and oops, we're gonna crack this hash, the MD5 that we were given. Now we'll see. So this is good that we did that initially. So John initially looks at this and tries to figure out what kind of hash it is, and it's like, oh, this is a landman hash, probably. We think this is a landman hash. And you're like, you do? Do you really think that, buddy? So we know that we need to give it the MD5 hash type, because we ran that hash identifier earlier. So we're actually going to do this again. And it says use the -- format equals raw -MD5. Now there's a lot of MD5s. How you would know that you need to use raw MD5 is just the fact that you've used John before and you've kind of run into this problem in the past. So we're just going to add -- format equals raw MD5. Oops. And it's going to run through the same process, except this time it's going to try and crack using the MD5 hash and not the landman hash type. And if you see here, we get some output. Let's talk about John output for just a second. So one of the cool things about CTFD is that it actually tells you not just who's getting points and like what team has points and stuff, but if you're the admin, you can actually see some more metrics. So you'll see how many missed guesses people have. What were the missed submission types? Like what were the wrong submissions and things like that. And it's great because I can, as a challenge builder, see how people are misinterpreting the questions, right? So I can actually see, okay, well, these people are, misinterpreting my question. I either need to write the question to be more clear, or, maybe there needs to be an earlier challenge that kind of helps people walk through how to use John. But what I was getting is things like this here, this output here. What this output, this highlighted bit here is that is the chunk of the dictionary that John is currently or just finished working on. Okay, so if you have a long running crack session, you can kind of hit enter and see like updates on what's going on and what its status is. And it's telling you like how fast it's going, as well as kind of what chunks of the word list it's working on. Okay. if you crack it, you're going to see something that looks like this. Now, this is the clear text password that it found. And then this is the user, if one is provided, that hash is associated with. So I didn't give it a user. I didn't give it like a shadow file or a password file or anything like that has a username in it. But if I did, that's where the username would go. Another quick caveat is if I run this again, and this is another thing that people were kind of messing up on, is like they ran it, they submitted like this as the cracked password. It didn't work. They ran it again, and then they weren't getting the output. Now you see here, you don't get any output. It doesn't even bother trying to recrack the hash. Okay, it says one password loaded, and then it says no password hashes left to crack. The reason for that is that John keeps all of the previously cracked passwords that it found. Okay, so if it already cracked a hash, it's not going to re-crack that hash again. It just doesn't waste its time. So we can actually add a -- show. Oops, probably have to remove all this junk. Why? Why are you being a butt? Don't be a butt. That's what happens when you go script. Here we go. Okay. So you have to give it the format because I guess it doesn't know otherwise. But so you can do a -- show and it'll show you what hashes have already been cracked out of that. The way you get rid of this, and you'll want to for a couple reasons. If your job is just to crack passwords as fast as possible, just get clear text passwords out there. Or if you're a CTF player and you just want to get a cracked password out as quickly as possible, you may want to keep this file around. I'll tell you about this file in a second. But if you're a pen tester, having a clear text credential is like half of it, right? You want to have that clear text credential. And if you get a hold of that clear text credential through password cracking, then you definitely want to be able to use that to pivot or to privilege escalate or whatever you want. And you're going to write up a finding saying, yo, dog, I was able to do this. But it is very helpful when you're writing a report to be able to include what steps were necessary to crack a password, how long it took to crack a password, how complex the password was, what techniques you needed to use, et cetera, et cetera, et cetera, et cetera. And if you're just reusing the fact that you cracked a password a month ago on a new report, A, that is an interesting bit of information, but B, you don't have all of that extra metadata involved. So your report, the detail in your report can suffer for that. So it's typical, for me at least, to have a machine that doesn't have any of this file on it so that I'm freshly cracking new stuff every time. That file is let's do this, .john and then john.pot in your home directory, okay, by default. And so this file keeps cache credentials of all of the previously cracked stuff. So we could delete that file and then recrack the password if we want. Okay. So if you ever crack a thing and it's just like no more passwords left to crack, and you know for a fact that the password is in your word list, then it's probably sitting in your john.pot. Another possibility is just that it's not in the word list that you have. It just might have ran out of all guesses. Okay. So we have, let's do this again. We have the password now. Now this was the flag for the challenge. Okay. So Omogoose was the flag for the first password cracking challenge, and you would have, gotten points for that. Then we move into the dynamically scored challenges. So in the CTFs that I was running, and I may change this, I'm not sure yet, but in the CTFs I was running, each category would have a 100-point challenge of just kind of like intro, here's how you do the stuff. And then everything after that was dynamically scored based on how many people solved the challenge and whatnot. So everything else was dynamically set up. So I have an unhackable crypto challenge, and I told you that I am not a crypto person. So when I say that a crypto challenge is unhackable, it's very likely incorrect. So let's read this. We've intercepted a communique from the village being, you know, the village in Untitled Goose Game. If you haven't played that game, then first of all, you are missing the F out. And second of all, you're probably not going to understand most of the references here. We've intercepted a communique from the village, but we can't read it. We think it contains a code phrase for league members to identify themselves to each other. So we really need to know what it says. See if you can crack this unhackable cipher. Okay. When somebody says that a cipher is unhackable, they are wrong. There is one cipher in existence that, if implemented correctly, is 100% uncrackable, or as uncrackable as anything else can be. And that is a one-time pad cipher. Okay. Now, we had, we being the Allies in World War II, have famously cracked a one-time pad. And the reason we were able to do that is because they were not using proper random generation methods to generate their one-time pads. The Axis wasn't. And additionally, they started reusing one-time pads as well. So the whole reason a one-time pad is so ridiculously hard to crack is because the one-time pads are unique and random, and it's nigh impossible to mathematically calculate what a one-time pad could look like. But what we have here, if you're familiar with what one-time pads look like, and if you're familiar with cryptanalysis in general, it is extremely common to do cryptanalysis, and one-time pads are actually chunked like this by themselves most of the time in 5-character chunks. And one-time pads that are complete, so if you're encrypting a one-time pad message, you're actually going to have 3 rows of data. You're going to have your plain text on top. You're going to have the one-time pad itself in the middle, and then you perform a mathematical calculation on the plain text and the one-time pad to bring out your ciphertext. And then you throw away the plain text and the one-time pad portion of it, and you send the ciphertext. What this is the bottom 2/3 of a one-time pad calculation. So we can actually open up like Firefox. And so you can do the mathematical, you know, calculation back and forth. And it's really just like adding and subtracting numbers, like the ORD numbers of characters, basically. You could do that. Or there's tons of like online one-time. Am I probably going to try and go through a proxy? And I definitely do not need to go through a proxy right now. Okay, so one-time pad solver. If you have seen me at conferences and you've seen me wearing a shirt, not this shirt, different me shirt that says Team Rocket Hacker Camp, and it's got a cipher on the front. This is actually the same cipher. It's not the same text, but it's the same challenge basically. Okay, so we're gonna put in. Oops. How is it gonna? Oh, this. Type the key there. Okay, so we're gonna put this, which is the one-time pad. I put that there. And we're going to put the ciphertext here. I haven't used this specific one-time pad yet, so this doesn't seem. This one I have used. Okay, so we're going to decrypt. We're going to put our message here. We're going to put, yeah, that was our message. We're going to put the one-time pad. Okay, so the interesting thing about this, and I think this is why some people had some problems with this, because I would get weird gibberish in the wrong answers boxes. And I think what it was is because people were seeing this and they weren't seeing English. But you have to remember that the way these things were written and the way cryptanalysis worked back in World War II is, since you were chunking it in 5-character bits or like blocks, that's what your output was going to look like. So the first word isn't theme. The first word was the. Let me make this a little bit bigger. It's probably not super big on the screen. The first word was the new secret phrase is, and then the secret phase is, excuse me, secret phrase is no more honk. Okay. So again, the crypto and password challenges don't follow the flag format. So the flag would, for this challenge, would be no more honk. And as I'm going through this, feel free to post any questions you have in the chat. Happy to dive a little bit deeper into whatever. So far, I think it's been pretty straightforward, but feel free. Okay. This one. I don't know, again, if you've run into me at a conference, before I started doing these CTFs, I used to have a business card CTF. So I have coins. Do I have coins here? I do. So I used to have this coin. I mean, I still have this coin, but I only have a couple left, so I'm not giving them out anymore. But so I used to have a coin that I had a challenge on my business card. So if you got a business card from me, there would be a cipher on it, and then once you solved the cipher, it actually led you into some other CTF-y stuff. And if you finished it and ran into me at a conference or saw me again in person, I don't mail them because they're expensive to mail and they're small, which is weird. If you see me again, then I'll give you a coin, or I gave you a coin for finishing it. What is the second challenge name? The second challenge name was Unhackable. Should have called it Unquackable, but that wouldn't have been as big of a hint. It would have been funny though. I now have these anyway. So I'd give away those coins, and the business card challenge was this specific cipher, and caused a lot of people grief. People tended to either get it immediately or not get it for weeks, and it's unfortunate. But it's called Shift the Key. That in and of itself is a hint. And then the challenge reads like this. Looks like the village updated their codes after you cracked the last passphrase. Our overseas operatives couldn't crack this cipher. I'm hoping our US office will be able to. It's all up to you. Now, that is a hint. That is not me being mean to other countries. It's weird living in America right now, but I'm definitely not anti international places. I love traveling internationally. This is a specific hint because what this challenge is a keyboard shift cipher. Okay, and so other nationalization localization keyboards will not work for this challenge, which is upfront not great, except for the fact that, again, there are online solvers for this. So you don't necessarily need a US keyboard for this, but there are online solvers. So between shift the key, keyboard shift the key, and the fact that overseas operatives couldn't, US operatives can, is a hint trying to get you towards looking at your keyboard. So one of my favorite when I'm doing, is it decode? Yeah. So one of my favorite solvers, like crypto tool sites, is this decode.fr. They're amazing. A lot of times when you're doing crypto challenges or whatever, it's going to be like some cipher, some variation of like ROT13 or Caesar cipher or whatever, and they've got all the decoders for that and a bunch of others. It's just a great site. So we'll do a keyboard shift cipher solver. And of course, the first one that comes up is that decode.fr. And here we're going to put in our ciphertext. And we're going to just kind of keep everything automatic. And we'll do a decode. And what it does is it actually does every single shift direction. This is close. Keyboard layout, we're going to use US so that it doesn't like do every single one. So this one's close. There we go. So use alphanumeric characters only. I'm going to show you what this looks like in a second. I'll bring up like an image of a keyboard. But so the passphrase is look out for the bonk. And again, if you've played the game, you know you can pick up the bat and like chase people with it. It's super funny as a goose. But let's take a look at a US keyboard. US layout keyboard. I do not endorse this site. I don't know anything about this site. Okay. So the way it works is this. In order to encode something using a keyboard shift cipher, what you do is you take your message and pretend you're typing it out. So T, if you're doing a downshift, would become a G. If you're doing an upshift, it would become a V. Okay. Or it might become it should become a V. If you're then H. If you're doing an upshift, it becomes a Y. If it becomes a downshift, it becomes an N. So that's how you encode something. And then when you decode, you just flip it, right? So if you have an N and it was upshift or a downshift to encode, then you upshift to decode and you get an H. That's all that's happening here. So when you have a G and you downshift it, it's going to become, so when you have a T rather, and you downshift it, which is what this is indicating, then the encoded version becomes a G. And then if you have an H and you downshift it, the encoded or encrypted version becomes an N, and so on. Okay. So that is the shift the key. That is a keyboard shift cipher. This is the other reason that I'm not a huge fan of like crypto challenges, because unless you really get into like PhD math, you're not going to be doing real cryptanalysis on modern ciphers. And if you're not doing real cryptanalysis on modern ciphers, what you end up doing is like guess the cipher method that this person came up with. It's the same reason I'm not a big fan of I don't even remember the name of it. Steganography. Same reason I'm not a big fan of steganography, because it just becomes a game of like, guess what the CTF maker was doing, like what they were thinking. And that's not, to me, it's not great for teaching. It's not great for learning, right? So I'd rather have more real worldy stuff. And frankly, I just don't have the math background to be able to make real world like crypto stuff. So let's get back into some password cracking, because that I do know a bit more about. Okay, this one I love. This one, not a lot of people solved. Very few people solved it on at BSides San Diego, and I think one, maybe two people solved it in BSides Oklahoma. When would you even use this in real world? The keyboard shift cipher? That's what I'm saying. You wouldn't use any of like either of those ciphers in real world. I mean, I guess one-time pad still kind of has a use, but the reality is like all our modern ciphers are way more usable than any of that. So that's what I'm saying, is like, that's why I'm not a big fan of crypto, because like real world ciphers are really difficult to break. That's why they're real world ciphers. So like, if you're not going to use those or you're not going to attack those, then you're just using like arbitrary rando ciphers that the person came up with. That's my point. Okay. So, this, however, this password cracking is real world. So this is something that not a lot of people got. And this is actually really huge. So the name of the password, or the name of the challenge, is Lose Michael, Need Thomas. And nothing against anybody named Michael, and it's not that I'm a huge fan of anybody specifically named Thomas, but the initials of that title, LM and NT, are going to be very important for this challenge. So an agent has been able to steal an administrator credential from the village's network. We need the plaintext password that will allow us to log into their Windows 2016 servers. This might require a couple steps. This is actually real world. So what happens is when you see a Windows hash, you see it in this like colon delimited format. The first section of that colon delimited format is the LM or landman hash. A landman hash is an awful, awful password configuration. Okay. What they do is they pad out, or they first uppercase everything. Okay, so they turn everything into uppercase. Then they pad it out to 14 characters with spaces. And then they MD4? MD3? No, they desencrypt it. That's what it is. They desencrypt it. MD4 is the one we'll talk about in a second. Okay, so they take... Oh, that's funny. Okay, so I skipped a step. They turn it into all uppercase, so they get rid of any of your casing complexity. So they lower the number of your key space. They put it all in uppercase. They pad it out to 14 characters using spaces, chop it up into two 17 or 7 character chunks, and then they desencrypt it. This is, I mean, it probably sounded fine at the time, but this is awful today. What it does is basically stops you from having longer than 14 character passwords at all. Like you just can't, it truncates it. It also lowers the entropy to just a 7 character length max password, and lowers the character space from upper lower to only upper for alpha. This makes it incredibly easy to crack because the most number of characters you'll ever have to crack is 7 character desencrypted, and des is super fast. It is not standard today. However, most corporate networks weren't created 3 years ago. They were created 15 years ago, or 10 years ago, or 20 years ago, or 40 years ago, or however long your company's been around. And so they have old infrastructure that uses older technology, and you will run into environments that, even though they're running on Windows 2016 and they're running like a modern forest function level for their Active Directory domain, that Active Directory domain wasn't created at that modern forest function level. It was upgraded over time, and so they still have these legacy technologies like Landman. So you'll see this first half. Now there is a specific, and I always forget what it is, but there's a specific hash that's basically blank. It means that the landman's not included. But if it's not blank, then this hash is the landman version of this NT hash. Now the NT hash is a bit better. It's like MD4 encrypted or MD5. It's unsalted, but it's at least a little bit better. So this is going to crack super fast. This maybe not as much, especially if you don't have it in your word list. But because we can brute force landman so easily, here's the solution to this challenge. I'll walk through the solution in just a second, but here's the solution to this challenge. Because landman is so easy to crack, you can literally brute force landman and then use the uppercase version of the uppercase plain text landman key as your dictionary to crack the NT hash. And so there's a couple hints here. First, we've got the LMNT for landman and NT hash. Then we talk about, we've got this admin credential, but we need it to work in 2016 servers, which is indicating that we need the NT hash version of this credential. So we'll go ahead and grab this hash. And then we'll like VI hash, and we'll just put it in here. Okay. And once again, it's not going to follow the SD flag format. It's also going to use RockU. And that is a departure from real world. In real world, you're going to use your own dictionary. So I have like a 50 gig, I think, 10 gig. I don't remember how big my personal word list is, but you're going to have a huge word list that you're going to use personally. But for these challenges, just to make sure that you can do more than one challenge in a day, these challenges, we give you the dictionary that you're going to use. So we're going to use John, and we're going to set our word list to word list Q, and we're going to run it on hash. Now it's going to do its auto check thing, but we already know what format it's going to be. So if it doesn't immediately pick up landman, which it should, then we can tell it format LM, and it does pick up LM as the format. Here's another great thing that I was seeing in the incorrect guesses forms is people were submitting either goose or horrible without the E. I said, if you were paying attention, that Landman chunks the password into 2 7-character chunks. This is giving you those 2 7-character chunks. Okay, so we have a second 7-character chunk of horrible without the E, and that is the first chunk. And then we have goose as the second chunk. Okay. If we had a username included in that hash, then that would be username 1, username 2 is how you would know. But that's giving us the 2 sections of it. Now, all we need to do is use horrible goose as our dictionary and run it through some sort of case permutation script. So if you're using Hashcat actually can use like mangling rules, and you could write your own custom John mangling rule if you want. We'll get into rules in just a second. You can write your own rule to do this. I panicked like 5 minutes before the stream and didn't have time to write a Python one real quick. So I found a Python script online. We'll look at this real quick. This is not my Python script. I added these 3 lines because it was outputting weird, and I was just like, I didn't have time to make this good. I know this is Python 2. No, I'm not a fan of Python 2. Everybody should be upgraded to Python 3. This is a shitty, hacky way to get different permutations, case permutations. Okay. So all it's doing is it's going through and it's just generating a bunch of different iterations of horrible goose and different capitalizations. So we're going to Python case.py, and it takes in a string. So we're going to do horrible goose. Remember to not do the E. I think this is what was screwing everybody up before, is that they were adding an E just because they're like, oh, horrible has an E in it. This doesn't. And I did that way just so that the 7 characters lined up all right. Okay, so we put that in here, and we're going to redirect it to my dict. Okay, so if we like head my dict, then we see that it's just a bunch of different iterations of horrible goose with different types of cases available for it. Okay, so we will run John again, except this time we're going to set our word list to my dict, and we're going to format equals NT. As we see here, is like it's possible that it could be NT because we have both hashes available to us, and we're going to run it again, and we come out with this different weird capitalization, right? It would have been very difficult to word list crack this, okay, unless you had that specifically in your word list, pointing at this screen, you know, wherever your screen is, unless you have that password like in your word list, like with that capitalization, it's probably not going to work. You're going to have to run, why don't you run a TTY shell? What? I'm not sure what that means, but, or I'm not sure what you mean by that. I am in a TTY shell. Yeah, I'm curious what actually you're asking there. So unless you have that in your dictionary, you'll have to run some sort of permutation rules, or you'll have to like brute force it, and the brute force is going to take forever. And this is a much faster way to do it. And I do this, I wouldn't say all the time because I mostly pen test like Linux environments, but I do this often when I'm in Windows environments. Okay, so this is the flag. I was getting a lot of, you know, horrible goose as the flag and things like that. All right, moving into rule of the land. Now, I mentioned the word rules a moment ago, and there are rules. And so in John, they're rules. They're just random, you know, you call them like mangling rules, I think is what they call them. In Hashcat, you have different like masks and different attack types and things like that. But in John, we have rules. So you can do, by the way, you can do all of this in Hashcat. I just don't because this is all in a VM. You can do Hashcat, not GPU accelerated, but why? Whatever. Anyways, I'm much more familiar with John just because, again, I don't do a lot of password cracking like in my day job. But we've got a hash here, and it says rule of the land, hint. Another credential hot off the Intel presses. We ran it through the word list that has been working so far, but it didn't work. We're not ready to rule these credentials out yet, though. rule these? Anyways, let's see what you've got. Okay, so it says, once again, even though it says they didn't have any luck with RockU, this specifically says that you can solve this challenge with RockU. Excuse me. So we're going to VI hash again. Get rid of that hash. Bring in this hash. And we're going to run John. We're going to do our same old that we always do. And it's going to go through and it's going to finish. What happened? Okay. So what mangling rules do is they mangle your guess somehow. Okay. So things like, it's very common for people to have a favorite password they love using. So let's say that their son's name is Joshua and they use Joshua for all of their passwords, but they started a new company and the new company requires that you have numbers in your password. And so what they'll do is they'll take like their birthday year and put it on the end of Joshua, or they'll put Joshua's birthday year and put it on the end of Joshua, or whatever. And how the hell are you supposed to, when you're trying to crack like, 4,000 passwords, how are you supposed to like research everybody's birthday and things like that? You don't. You create a mangling rule that adds either 2 or 4 numbers on the end of every single password attempt or every single entry in the dictionary. That is a reasonable birth year. So anything from 1900 on, or you can even say, what if it's a great grandfather? So, 1800 on, or really just any combination of 4 or 2 numbers. And you can, instead of writing scripts to like build these word lists for you, you can use rule languages, which are really just kind of these fancy regexes or like sed-awk style things that say, hey, I want you to add 4 numbers, whatever numbers, okay, 4 times at the end of every password attempt. And it's very quick to be able to write really complex mangling rules and really turn your, 4 million line word list into a 40 billion line word list. So we're going to do that now. We're going to just do, so John has some built-in rules. So we can just tell it like, hey, John, use your normal rules, or we can build our own custom rules. We can download rule sets from other people. There are other rules that are built in that you just have to call explicitly, all that stuff. So we'll just run -- rules. Let's see if we come out with it here. I actually don't remember which rule set gets this. It was either this one or there's a top 64 rule set, I think. Notice how it's taking longer. Here we go. So notice how it's taking longer. So what it did is I believe, if I recall correctly, the thing that's the word that's in the word list is silly goose, all uppercase with O's instead of zeros. But one of the mangling rules, one of the rules that defaults comes with John, is it will take letters that can look like numbers and flop the numbers in. So some of you might know this as leet speak, or at least a subcategory of leet speak. This is a very common user thing to say, oh, well, I really like password 123, but everybody tells me password 123 is not secure enough. So I'm going to change the A into an @ symbol. Got him. But we have rules for that, right? Like we did, like John has rules for that and we just used it. So that is how we solve this. Now, like I said, these are noob-ish style challenges, right? We're not going super deep into having to custom write your own rule or anything like that. There's a whole deep well of rules and mangling rules and masking and all that stuff out there that you can explore. The point of this is to expose you to this concept so you can say, hey, this is really neat. I think this could help me in my job. I think I'd like to know more about this, and then go off and research it on your own. Okay. And then last one here, the last challenge today for password cracking is security through obscurity. We know you said to stop bothering you with credential cracking, but we've already applied the word list, rules, masks, brute forcing, etc. We just can't think of any other alternatives. We really need your help on this one. Okay, so if you do them out of order, this could actually be a hint for the previous one saying, oh, rule sets, what the heck are those? And then you go back and do rule sets on the previous challenge. That's fine. You can do them out of order in my CTFs. I don't enforce an order on most of them. Okay, so earlier, if you remember, set your Wayback Machines to the very first challenge that we did. If we try and John word list equals share word list .txt, I could have just hit up a bunch or Control R or whatever, but I guess I just type. So if we run this, we see that it's auto picking landman again, and then we see all of these different hash types available to us, like all these different hash types. Nothing worked. They said that they ran rules and masks and brute forcing and all that stuff, and like maybe they did. So we don't have to. We could try it anyways, just because maybe they didn't use the same rule set that we do or whatever, or we could try it again. But let's assume for the moment that they know what they're doing, and that's not it. Let's figure this out. So if you remember the hash identifier, hash ID, oh, this helps if I spell hash correctly. Run hash identifier, put in our hash, and we see all these different hash types that it could be. But there are some alternatives. So we can try MD5, so let's try that. Ran through, didn't find it. Okay, so that's not it. It already tried landman. It already tried landman, so it's not that. We can try RDadmin. We could try NTLM, which is not a hash type so much as it's like an authentication protocol mechanism, but don't get me started on that. There are a lot of other opportunities here, a lot of other hash types that are possible here. I'll save you the going one by one until it works. I also decided to choose a hash type that's relatively towards the top, so you only have to go through a couple if you are literally brute forcing. But pick another common hash type, and this one is MD4. So this is really just to expose you to the fact that there are other hash types that passwords could be hashed in. It may not be a common one that an operating system picks. However, there's a lot of web applications out there, and for some reason, web application developers love to like invent their own authentication mechanism, and they always they do the weirdest hash types I've ever seen in my life. And so it's entirely possible that somebody decided to do MD4 just because it was off the beaten path and nobody ever cracks MD4, right? So we'll run that and we'll see Mother Goose is the clear text credential for this. And that's the end of the password crypto section. So that's every password crypto challenge that I had in the CTF. If anybody has any questions on any of that, whether it's a technique or why that's relevant or anything, please feel free to ask in chat. Otherwise, I will move on to, I guess we can do system challenges next. You'll notice that there are, do I count the characters? Do you count the characters? For which challenge? Oh, for the hash type, I'm assuming. So you can, different hash types have different lengths. So, a SHA-1 is not the same length, like actual length, byte length, as like a SHA-512, or MD5 is not the same hash length as a SHA-1, etc. So you can use that to help narrow down which hash type it is. I would assume that hash identifier would do that automatically, and if it's not, then it's not that great of a tool. But yeah, you absolutely can use that to help determine what hash. So the hash length itself can be an indicator what hash algorithm's being used. The character set is another indication of how algorithms being used. Some only use alphanumeric, some only use alpha, some only use hex characters, whereas other ones use like the full alpha character space. All of that can help you kind of whittle down which hash is being used. honestly, that's not a very common thing that I run into. I have in the past ran into some wonky web applications that do some really funky stuff. So it's just important to know that, you know, John supports a bunch of different hash types, and there are people use weird hash types for hashing passwords sometimes. But yeah, that's a great question. Okay, so let's see here. Oops. I'm going to open up another. Window here. And so the way I have these set up, I built them as Docker containers. And the way they were initially set up to run is I have a Docker compose. So if I go into like the challenge containers, I have the 3 different areas. We'll go into system because we're doing that first. And so I've got a Docker compose file, and it just launches all of the system containers on the host. And so I had different hosts. And so I'd have all the system hosted on one host, and I'd have all the web hosted on another host, and just a way to kind of load balance resources without getting like super into like orchestration, because I just didn't have the time to build it. It worked really well. I was really happy with the way it worked, and it was super easy to like just, if I needed to bounce something, I could run in and just rerun Docker compose, and it would fix whatever was wrong. The new format, we'll take a moment to talk about the new engine that I'm building. So one thing that really bothered me with this, 2 things that really bothered me with this system is the lack of orchestration. I just did not build it cloudy, really, to be honest. I built it super manual because I had like I procrastinated because of course I did, but I had like a week and a half to basically build the CTF before BSides. And so I didn't have the time to do it correctly. I had the time to do it the way it worked the first time. And so the non-scaling, you know, a couple hundred people playing the CTF, it worked pretty well. If I get into the thousands somehow, it would not work that well. The administration was kind of a pain in the butt because I wasn't using like ECS. I was using like EC2 hosts that I'd have to SSH into and muck with the Docker daemon on each host. And then the last one, and this is the real stickler, this is the one that really made me build a whole new engine, is that when I'm writing challenges that multiple people, and if you use Hack the Box, you've ran into this. Nothing against Hack the Box. I love Hack the Box, but this is a real problem when you write challenges, is if you're writing a challenge where you expect multiple people to be doing the same challenge on the same box, it precludes you from a whole bunch of different types of exploits and misconfigurations. Basically anything that requires write access, you can't do. Because if you're stomping on files, if you're writing to logs, if you're doing all this stuff, if you get any more than like 3 people working on it, it's going to get super cluttered and super broken really, really fast. The other thing is you have to really pay attention to the permissions that you allow your users to gain. If they gain root, they can delete flags. Like there's no getting around that. Like there are tricks where you like make it read only and make it owned by root. But if you become root, you can do whatever the hell you want on the system. So you can never have like prevesks to root in shared challenges. So what I'm building is an engine that you log in and as the user, you'll say, okay, I want to work on this challenge now. And if you've done Hack the Box challenges, not the boxes, but the challenges, it's sort of like that. But you basically say, I want to work on this challenge, and it'll launch a container for you. And that's your container. And so I can write all kinds of crazy challenges that, you know, have stomping on files and web log pollution into RCE and all kinds of fun stuff. And I also get to be a little lazier with permissions. So I don't have to, you'll see, I think in systems, there's like a couple wonky stuff. Like you don't sudo to root, you sudo to another user because I'll show you when we get there. But yeah, so that's kind of where I'm going. That's what I'm building right now. And I'm super excited. Once I get it working, at least to an alpha state, I'll probably do another video kind of showing off some of the functionality. It won't be a UI thing, but it'll be fun. Hey, Erica, it's good to see you. Thank you for joining. All right, so so to run these, you literally just docker compose up and daemon mode if you want. This, excuse me. I guess I should have tested these. I haven't built them. Cool. These are in a private GitLab. You can't get access to them. Sorry. I'd love to open source them, but again, I don't want to open source all my CTF challenges. I'm fine doing walkthroughs here and there, but it just wouldn't be fair to people who haven't exfiltrated all of my challenges. There's no secret sauce. It's not like I'm jealously guarding them or anything. Like, once somebody gets root on a challenge, there's really nothing technical stopping them from exfiltrating the entire challenge and like working on it themselves. I get it. But I'm just not like making the repos public. Another point of fact, when we go over here, these are the domain names for the challenges back during BSides San Diego. Obviously they're not up. These domain names aren't up, and I'm just going to be running all this locally, so you can't actually get to it. But it gives the login information. So we'll have these here. Oh, man, I really should have built these like previously. Sorry about this. They're not slow to build. So probably what I'll do is I'll get these up, and then I'll also build the other two categories like while we work through the system stuff. Any questions, comments, feedback on the CTF idea? Obvious flaws that I completely missed? Stories about your day? I don't know. How is the lighting, by the way? So I got a couple key lights, and they work really well when they're pointed at me, but that also means that I've just got these two really bright lights in my eyes. So I have them faced at the wall right now, and I feel like it's okay. But if it's a little dark, let me know. I'm not going to muck with it in this stream, but I'd love to know kind of feedback. This is only the second stream I've had a camera on. So. Oh man, you just woke up. That is not going to do well for your jet lag, your fake jet lag. Oh my God, this is so slow. I apologize forever on this. I really should have built them ahead of time. Actually, let's set up another one. We'll go to web. What's the other one? Recon. Patrick, I am not already done. We finished password cracking and crypto, and we're moving on into the containers, the challenge containers. So we're about to move into system. Erica, as soon as you move to Australia, you're gonna like get onto like Ireland time zone is what I predict. So my first time ever flying overseas was only a couple years ago. I flew to Spain, and I flew to Spain for work, and I got over there and I thought that I had beaten. Wow, web went really fast. Everything else is taking forever. I thought I had beaten the jet lag. I was like, that first day I was in Spain, I was totally fine, and I was like, okay, cool. Day 2, fine-ish, a little tired. Day 3, I was completely screwed, and I was screwed the entire rest of the week. Luckily, it was for work. It wasn't for just like vacationing. So I was able to muddle through my work day, and we went out a couple times. I got to see Old Town Sevilla, which was really nice. Saw the biggest Gothic cathedral in the world, which was super cool. But I didn't really like maximize my time there. But so when I flew back, evidently my body just decided that I was just going to keep going east, and I ended up like migrating across the world in my awake zones, and I settled in Hawaii time zone for like a week and a half. It took me almost a month to fully get over that trip. It was awful. I did not do it well. After that, I read up on international travel practices. Uh-oh. There's something wrong with the DNS server. Shit. I don't know why that wouldn't have worked. I may have to go in and manually boot up DNS once we get to that challenge. Actually, I could probably just show you the challenge using somebody else's DNS server, to be honest. I was shocked by this. When there's a challenge that I made, that's a DNS zone transfer, thinking that it would just be a real good kind of intro level challenge, but a lot of people struggled with it. I didn't realize how few people have actually done DNS zone transfers before. So that's one of the challenges. Okay, they're up. Cool. Actually, I can just set these to go as well. And they can get going while I do this. Okay, so we're going to do the system challenges now. So the first system challenge we have is called Time Turner. And so all of the system challenges are Darkwing Duck themed. So if you're not familiar with Darkwing Duck, they are on Disney Plus. I found that out the other day. We rewatched a few episodes. They're adorable. Very old. They were like my childhood. So we're talking like, I actually don't know when that was. Maybe that was early 90s. Maybe I wasn't a small child, but it was certainly me growing up. But you might lose out on some references here. So Darkwing and Launchpad have gone dark. We know Launchpad's login information to a target server, but the codes were in Darkwing's files. Log into the server and see if you can find Darkwing's password. Okay, so we are going to SSH as Launchpad. Yeah, so these are all uppercase, but the users aren't actually uppercase. And so that was fixed in the BSides Oklahoma documentation. But and we're just going localhost here. So we're not going to that address, and it's on port 2222. And his password is falling with style. Okay, so we're Launchpad. We need to figure out how to privilege escalate to Darkwing. Okay, and this is kind of what I was talking about. Like, you can't privilege escalate to root, or else you allow maybe less ethical CTFers to muck with the challenges for other CTFers, and you don't want that. So we're going to be escalating to Darkwing. So there's a bunch of different ways to do it, but the specific challenge here, the reason I'm not going to go over the other ways to do it is because there's challenges for those, so we'll get to those in a minute. The way we do it here is by checking out history. And so if you look in the history file, there's a very obvious formatted flag here, and that kind of draws your eyes initially. But let's take a look at what actually happened and why a flag or a password ended up in history in the first place. So if we see here, we see that Launchpad ran the US command instead of the SU command. And what happened? Well, Launchpad got an error saying, hey, the US command doesn't exist, and just returned to prompt. Now, if you're not watching the screen, if you're like touch typing, or you're looking at another screen, or you're talking to a coworker or something, you may not have noticed this. Or sometimes your brain's just moving so fast, you've got muscle memory that's just like, okay, SU, or, SU sudo dash, boom, 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 type in password, boom, boom, boom. And like, you do all that before the fact that your eyes see an error catches up, like sends the signal to your brain like, hey, there was an error, don't type the password. This happens a lot, way more than you think it would. Another way this could happen is if they ran like a script with a password in it. The passwords ends up in history files all the time. This is not an arbitrary thing. I find this on pen tests all the time. The Slacks that I'm in with other pen testers, they complain about finding it all the time. It's just very common. Okay, so they did the US Darkwing dash, typed in their password. Oh crap, that was an error. Ran su Darkwing, and then did their business, whatever they needed to do. Okay, so this is the flag for the very first system challenge. The next challenge is called Pseudo Admin. Pseudo Admin. I wonder what this one is. So it's called Pseudo Admin, and the description is looks like they've changed Darkwing's password, but they had to keep his account around because it's hosting some sensitive files. See if you can break into Darkwing's account and read the critical file in his home directory. Okay, so they needed to keep his account for some reason, and we're given Launchpad credentials again. So we'll exit out of here. Not 2222. We're actually on 2223 this time. Following with style is the password still. Okay. And so now it's called Pseudo Admin, and Pseudo Admin sounds a lot like Sudo Admin. And of course, this is playing on the fact that a lot of people think that sudo is sudo, and it's not. It stands for switch user do. So we're going to check that out. Now, if you're not familiar, and some people aren't, there is a way that you can list what capabilities you have with sudo. So you can just enumerate what rights you have. And so we see here that we have an entry that allows us as Darkwing, we can, with no password, so we don't have to enter our password, which this is golden if you're a pen tester. A lot of times we gain access to accounts without knowing the password. We steal an SSH key, we gain some sort of like remote code execution, we break a web server, whatever it is. We may have access to the account and execution as the account, but we don't actually have its password. And we don't want to run, password and change the password because A, that'll get in the way of our customer doing the work that they need to do, and B, it'll tip people off that something's going on. It's just usually like a last resort kind of tactic. So finding this no password clause in the sudoers file is amazing, but we happen to know the password, so it doesn't really matter. And as Darkwing, we're allowed to run user bin vi. Okay, we can't run anything else. We can only run user bin vi. Do not, I see people do this sometimes. Do not put relative paths in your sudoers file. Like, do not do that. Do very explicit paths to binaries that they do not have write access to. Okay, that's the other thing is do not say that they can run no password to files that they can copy like a SUID binary to or something like that. Like, just be careful with sudoers. A lot of people are very blasé. In fact, we'll get into a very silly example of how wrong this can go. A real world example, by the way. It'll sound contrived, but it's not. I found this on a test. How wrong sudoers can go. Okay, so we can, as Darkwing, run VI. So you can actually set what user. Sudo doesn't have to be root. Okay, so it's a lot like SU. SU is switch user. It is not super user. Okay, so SU is switch user. SU do, super user do is switch user do, not super user do. So we can, by default, run things as root if we're allowed to, but we can use the -u to set the specific user we want to do. So we're going to say Darkwing, and we want to run user bin vi. Okay, so we're running vi now as Darkwing, assumedly, we assume. But let's do the very popular vi escape. And if you're not familiar with it, you you hit colon to go into command mode, bang, bash or sh or whatever. And we drop to a shell. Now, this is It's one of those classic examples of it's not a vulnerability, it's a feature, because it is. It's just can be abused if you are not aware of this kind of stuff. So what it's actually for is when you're programming in VI, you can use that to like run the script you're programming or do some other thing. You can programmatically interact with the system like while you're developing, and it's helpful, it's handy. But if you're not aware that this can happen and you allow people to sudo VI, then they're just going to drop to shell and use that as a pivot or privilege escalation. Okay, so if we run ID, we can see that we are Darkwing. And so we'll go into home Darkwing. And we see that the flag is there, and so we can cat the flag. And the flag is, I am the parking meter that expires while you shop. And that is a knee slapper if you've seen Darkwing Duck. If you haven't, I just seem really old and irrelevant. And that's also true. So anyways, that's the second challenge. So we'll back out of all this, and we'll move on to the next system challenge. Excuse me, I've been talking a lot. Surprise, surprise. Luckily, I brought a second pint of water. Okay, next, we have a challenge, deny, deny, deny. Your sudo trick was pretty good, but they've wizened up a bit and increased their security. Elevate to Darkwing and read the flag in his home directory. Okay, this is a funny one. And this is a funny one because you're really not going to believe that this is a real example, but it definitely is. Okay, so it says they've wizened up and increased their security. Let's run sudo -l again. So, as is common in computer scripting languages and pretty much any computer nomenclature, an exclamation point or a bang means no, or means deny, or means accept, or whatever. So the way you read this, and if you've interviewed with me and gotten to the technical interview, you've probably seen this exact challenge before, and I have you walk through it. So you're getting a, as is most of my streams, you're actually getting some spoilers on how to interview with me, some answers on that. But the way this reads is, as Darkwing with no password, I can run any command I want, except I can't run user bin vi. I can't run user bin vim. I can't run user bin apt. I can't run bin bash or bin sh or bin dash or bin su or bin cat or bin more or this or that or the other thing. So basically it says, hey, look, this user is an administrator. I just don't want them to be root. So I'm going to allow them to do whatever they need to do. I'm just going to deny all of the bad stuff that they can potentially do. This is a very classic security tactic in all disciplines. That's the explicit deny. It's the, okay, well, I'm just going to, just close off any potential holes that they could use. And it doesn't work. It's bad. It's not great. Sometimes you have to do it. Some people, it is the smoothest path forward, and the risk isn't very high. So they do it, and fine, if that's your argument, whatever. But generally, the fact of the matter is that specifically the reason that you're doing the lowest friction path forward is because you don't have a lot of time. So you're going to spend 10 minutes thinking about all the awful things somebody can do, and you're going to explicitly deny all of them. And then some attacker is going to come along, and they're going to spend 11 minutes thinking about all the bad things they can do, and they're going to come up with n+1 bad thing that you didn't think of, and they're going to get in. And I'll show you how that works. So sudo is a very explicit thing, and because I can't run vi or vim, I can't run user bin vi, but I can copy user bin vi to here, and then I can sudo u darkwing vi, perfectly allowed to run that. I'll privilege escalate in a minute, so I'm not going to escape out there, but I'm just kind of showing stuff. So similarly, I could copy bin dash or bin sh or bin bash to my home directory and, run those. And all I need is read access to those binaries to be able to run that copy. Like it's not like I have to stomp on them or anything. Another thing, and this is my favorite thing, is if you notice, sudo is not explicitly denied here. So I'm not sure if this will actually work because I don't remember Darkwing's sudo. But if this were root, sudo would work. So we could run sudo. And when you run sudo, you're now running this as Darkwing. Okay, so you're now running sudo as Darkwing. Darkwing, or this is where it's a little contrived because I'm doing it as Darkwing, but normally this would be root. Root doesn't have any explicit denies. So you could actually sudo. So if you're just doing this as root, you just do sudo like I or sudo su dash or something like that. This was the funniest one when we came up with this. When my buddy and I first stumbled onto this on an engagement, we spent probably the next 2 hours just coming up with like every single way we could break this explicit deny rule. So you can do all kinds of fun stuff. Let's see if this will work. I don't think I gave Darkwing any specific sudo stuff. No, because he can't do stuff without password. So root can do sudo without password, and that's why sudo will work. But anyways, we'll do our sudo udarkwing.vi, and we'll do our spiffy vi escape. Home Darkwing again, and there's our flag. So we'll cat flag. Let's get ridiculous. One of his taglines was "Let's get dangerous." So that's where I know I'm funny. Okay, so that's deny. So hopefully we learned never, ever, ever to explicitly deny sudo. This is just not a great idea. Excuse me. So I usually go away from the mic. I apologize for that. Okay, and on to, the last system, Polymorph. What do you mean by stomp? So stomping is a colloquial term for overwriting. So file stomping is basically overwriting a file with malicious content or with whatever content helps you. Also, so timestamp stomping is another, or time stomping or date stomping is just overwriting a timestamp or a date. Either to hide an access time or to, change the last time it was modified or whatever. Stomping's just overwriting, basically. Okay, so last system challenge, we got Polymorph. Some of you may already know what this is going to be, but some didn't actually. So some people thought this was like a polymorph, like a worm, or there was going to be some malware that they needed to analyze. So I guess I kind of missed that. But really, it's about changing permissions. So the league thinks they finally closed off all the escalation methods, but Darkwing might have had one last trick up his sleeve before disappearing. Elevate to his account. So we're going to SSH in on port 25. Yes, launch. Falling. Yeah. Falling with style. Okay. Let's talk about another very common escalation method in Linux, or at least a very common CTF escalation mechanism in Linux. Let's talk about the setuid permissions. So if we do a find command and we look specifically for perms with 4,000. So a couple things about this command. So the 2 into dev null, when you're not root and you're running a find command, you're going to get a metric ton of errors, like file not found or permission denied or whatever errors, and it's just going to pollute all of your output and makes it harder to to see what you're actually looking at. So I do 2 into dev null, and that redirects the standard error, which is going to be all of those from permissions denied errors, and redirect them into dev null so they just don't get seen. For the perms, normally the way find works is that you have a dash and then your search directive, your search like directive term, or your search, yeah, your search directive. And then immediately after that, you're going to have the term that you're searching for, or the parameters that you're searching for. And normally it doesn't have a dash. When you're searching for perms, what the dash says is that I want the 4-bit in that fourth bit set. I don't care what any of the other perms are, but I want that one set. If you didn't have the dash, then it would only look for files with the parameters of 4000, like explicitly 4000. And that's not what you want. You almost never see like the set UID bit set and literally nothing else set. And in fact, this specific challenge, because you're not escalating to root, and I had to do some fancy group permissions, missing the dash here won't even find the set UID binary that we're looking for, because it has the set UID binary and the set GID binaries bit set. So all this is saying is I want at least 4000 set. We can actually, let's do this. So if you're not familiar with what 4000 means, or just Linux permissions in general, here we have read the permission bits, and some of you might be familiar with this already. So you've got your read, write, execute, and this is for the user, the owning user. You got read, write, and execute for the group, and you got read, write, and execute for everyone else. Okay, and you can actually see read, write, execute here. You didn't see the X before, but it's read, write, execute, read, write, execute, read, write, execute. The way those are set up is those are actually binary. Okay, so if you look at this, this is the ones position. So this will either be 1 or 0, and that will indicate, a 1 will indicate if there is a execute permission in that bit set. You've got the 2 set, so that's either a 2 or a 0, and or I mean that's 1 or 0, but it signifies a 2, and that is going to be the write permission. And then you've got the 4 place, and that's either set or not, and that's going to indicate whether or not you have the read permission. Okay. When you bundle all of those up, you're going to see, and sometimes you'll see something like this, like a 777 file. When you bundle those up, each one of these places is 3 of these. Okay, so 7 means that you have the 1-bit set, the 2-bit set, and the 4-bit set. Okay, so you've got 1 plus 2 is 3 plus 4 is 7. So you've got all of these bits set for other. Then you've also got 7, so all 3 bits set for group, and then all 3 bits set for the owner. In fact, this specific file that I'm looking at, so read, write, read would actually look like this. Okay, so this is how those binary things work. I know a lot of people will do like A plus X, or they'll do like user plus X or something like that, and they'll do the character version of this, but that's how, if you learn the binary, how it's actually laid out, then you can do it in C, you can do it here, you can do it however you want. And it's relatively easy to remember if you just remember this is the 1's place, 2's place, 4's place. And then this is 1, 2, 3 of those. Now, what we were doing up here is 4000. This is not for this area, okay? It's not denoting that it's a directory or a link or something like that. What it is for a magical set of bits called the set UID bit, the set group ID bit, and the sticky bit. And these are mostly put either on the execute bit, or I think the write bit on group, if I'm remembering. So what these do is the set UID bits basically mean that when you run an application or you run a binary with a set UID or set GID bit set, it's going to run that binary as if you were that user. Whoever owns it or whoever the group owner is, you'll run with their permissions instead, called effective UID or effective group ID. A sticky bit is applied to directories, and that means that if you write a file into a directory, it automatically gains that group's ownership. Okay, so it's a way that you can have shared directories that a lot of people are contributing to, but it keeps the group owner correct, or it keeps the group owner what it should be. It's just a way to kind of organize and keep files, shared directories working. So let's go back to our find command. So we're looking specifically for the setuid bit set. Pardon? Is it perm, not perms? Yeah, okay. I was incorrect. That was a syntactical error. Okay, so we've got a few standard setuid binaries here, and setuid binaries are not bad by themselves. Okay, there's a lot of normal setuid binaries. In fact, the way I tend to get people to look into setuid binaries on their own, like especially if they're asking for help with like this challenge or this style of challenge explicitly, is I ask them, I say, how does changing passwords in Linux work? Okay, how do you change your password? And inevitably they say, okay, well, I run the password command. I'm like, okay, cool. But like, what does that do? And then they might come back a little bit later and they're like, okay, so you run password and it changes your Etsy shadow, or I'll say where our password's stored. And it's like, okay, to change your password, you have to update Etsy shadow. And they're like, okay, great. Yeah, we got that. And I'm like, okay, but you run password and then password updates Etsy shadow, but only root can read or write to Etsy shadow. So how is the password command doing that? And the answer is the fact that password is a setuid binary. Ping used to be a setuid binary because you used to have to set up a raw socket to be able to get like network packets off of the wire. So you'd have to open up a raw socket to send and receive an ICMP echo request packet. And so ping used to be a setuid binary. Sudo is a setuid binary. Mount, the fact that you as a non-root user can mount and unmount file systems requires root permission. So that's a setuid permission. So there are normal setuid permissions, but we have a very obvious looking elevate to Darkwing binary backdoor that Darkwing left for us. Is this contrived? Yes. Is this CTF meant for you to solve like 20 to 30 challenges in an 8-hour period? Yes. So of course it's a little contrived. In 504, we have a network analysis lab where you're actually like analyzing router configs and switch configs and stuff like that. And the ARP poisoned, or some of the not just ARP poisoned, but some of the MAC IDs are like a. And I've had students be like, but that's totally unrealistic. And I'm like, I know, dog, but this is like a 15-minute like exercise, and I didn't want you spending 12 hours looking through MAC addresses, because in the real world, that's what you would do. We want you to do the analysis, not like get caught up in which MAC address belongs. So that's what this is. Okay, so we have a setuid binary. So if we look at this, we can see here that an S is set in the owner bit. Okay, so the execute S is set. When we run this, our shell changes. Interesting. So if we run ID, nope, we're still Launchpad. So finding the setuid is only the first part of this challenge. If we run environment, we see that we're running inside of a bash shell. If we exit, oops, we go back to our initial Launchpad shell. So what is happening here? Like, run file on elevate to Darkwing. We see that it's a setuid elf. Cool. What if we run this with H? Oh, does bash not have an H? Do V maybe? What is... So if we run that with -- help, we see that we're getting bash's help. Interesting. So if we run diff on bin bash and our binary here, there's no differences. It is literally just a copy of bin bash, but with the setuid permission set. Now, there are certain binaries that are aware that setuid is a very bad thing. And what they do when they execute is they look to see if there is an effective user or effective group ID set. And if there is, it unsets it. Bash does this. GDB does this. GDB does it, which is a great idea because you could run like any setuid binary, like change or like password, for instance. You put a break literally anywhere, and then you run it to break, and then say insert, sysexec bin bash, just like into the place that you're executing, and then continue, and it'll drop to bin bash. If it were to respect your effective user ID or group ID permissions, you could basically escalate on any Linux system. So there are a lot of binaries out there that don't respect setuid permissions. However, there is a way that you can force bash to do this. So we're going to man bash, or I guess we could have just done this like in a, here, let's do this. Okay, so we've got our bash, and if we look for, it's not even like heavily documented here. It's kind of this like not well, it's kind of this hidden thing. So here it tells you in kind of the subtext, and again, there's no entry just for -p for bash, but if you read through basically everything, and you can find like Stack Overflow questions where people are asking about like, why doesn't bash do setuid? And some people will say, okay, just do -p or whatever, but they don't really explain it. But here in the manual pages, it says specifically, if -p option is supplied at invocation, the startup behavior is the same, but the effective user ID is not reset. Okay, and that's huge. That is what would allow us that is what would allow us to run the setuid with the effective user IDs that we're looking for. So if we run this, but we do it with -p, now if we run ID, we see that we have an effective user ID, an EU ID as Darkwing, and this is actually a problem. This container might not be working very well, which is not good. So if we go to home Darkwing, yeah, okay. So this isn't great. This is broken. So if you'll notice, we've got Darkwing's home directory is owned by root. And again, this is nonsense that you have to do to make sure that people don't ruin your game. But it's owned by root, the group of Darkwing. So no one can come in as Darkwing and just start deleting stuff and stomping on files and whatnot. But they should be able to get into it and read files in there. So get the flag. But something's going on with that challenge. So let's go into here, and you actually get to get a behind the scenes look on how this is made. So it's just a Docker compose that's setting up the networking configuration that also calls the Docker file. And oh yeah, I don't actually set that correctly. That's not great. Was that set that way for... People definitely solved this challenge, so I'm curious, like, if this got changed somewhere, or... Nope. Weird. I wonder if I had to... I wonder... Okay, so probably what happened is, and again, this happened like a while ago. I'm guessing what happened was somebody found that problem during BSides San Diego, I went in and manually fixed it on the challenge machines and not in Git. Then when I did BSides Oklahoma, I probably forgot about that, then had to go in and fix it on the challenge machines. So anyways, we're going to do a Docker compose down. Up D, and this will go much faster because it's not actually building the VMs or building the containers. It's just stopping them and bringing them back up. Okay, so if we do find perm 4000, okay, we see it. Do an LSAL. Oh, I think I have to rebuild it. I think I have to rebuild it. Okay, I'm not going to mess with this right now. I'm not going to troubleshoot this like on the stream. This is the solution. The meat of the solution is this. This is the trick. Like once you discovered what -p does, then you solved the challenge. And this would have worked even like this would have worked also even without fixing the Docker or the Docker file, if I didn't have to worry about people like writing over stuff. Okay, so any questions about the system challenges? Let's see. Oh, I got some stuff in chat. Sorry about that. So along with these system chals at a previous job, I needed to run some root commands to fix a broken server. Didn't have perms. What I did have was a special set of, was a no password sudo permission to run a writable script. Oh yeah. Yeah. Yes, that is, a great call out, Rhino. Hopefully it's pronounced Rhino. Sorry if it's not. But yeah, like so I used to do this as a sysadmin. Like this is not a only idiots do this. I mean, I'm probably an idiot at times, but this is not like a boneheaded mistake. Just people do not take the time to think through the implications of the changes they make. And so absolutely, like saying, oh, you can't have root, but you can have sudo permissions to this file you can overwrite, like is just as good as giving them root. A lot of my early hacking was as a sysadmin, losing access to a system, needing to gain access to it again, and figuring out how to gain access to it. And that's what really got me, aside from watching like sneakers and stuff, that's actually what got me into wanting to be a hacker. Monsters asks, hey, got my OSCP booked in 2 weeks. Any advice? Oh, man. Yeah, lots. I mean, just study, right? Like if you know the material, you can get through the OSCP. If you don't know the material, you're probably not going to do it. TJ Null has a pretty good set of Hack the Box boxes to go through. I would not recommend just doing all Hack the Box boxes because like a lot of Hack the Box stuff is actually harder than the OSCP. I have not done the OSCP in several years, so the test has changed significantly, but I do have an employee that just recently went through the newer version, and he said that doing the prep scenario in the course materials was really handy. Yeah, just practice. Enumeration is king. Learning post-exploitation and really all learning post-exploitation is just learning to be stubborn and look at literally every piece of information and figure out how it is important. But yeah, there's not a lot I can give you. I mean, it's been, oh man, how long? I would say 5 years since I took it. I don't actually remember what year I took it in, but it's probably been 4 or 5 years now. Yeah, good luck. Get plenty of rest, take breaks. That's the biggest thing. It seems like a nonsense thing. Like when people ask for suggestions for OSCP, they're looking for like, what things should I study? And the biggest thing is take breaks. Set an alarm every hour to make sure you're not rabbit holing on something and that you kind of like force yourself to say, okay, am I making progress or am I just beating my head against a wall? If you're just beating your head against a wall, move on to something else. And then every 2 hours, force yourself to get up for like 15 minutes, make some tea, make sure you're eating and not just eating like not just consuming food, but like healthy food, and drinking water. Like so many people don't take care of themselves during the OSCP. And I think that's super detrimental. Another question, what do you need to get a sysadmin job? It depends. I mean, I had like 3 or 4 years of help desk before I got my first sysadmin job. But I wouldn't say that that's required. Like my first sysadmin job was like a mid-level sysadmin job. It wasn't a junior or anything. Junior sysadmin jobs, you can basically get like out of college or with a little bit of self-taught Windows or Linux administration, like knowledge and stuff you can do at home. VirtualBox is free and it's amazing, for like teaching yourself server operating systems. That is not like virtualization was not really a thing when I was learning. So I was like dual booting, like Linux. And honestly, that's one of the reasons that I didn't become a Windows sysadmin is because it was much easier for me to learn Linux, and BSD server, administration at home on my own than it was Windows, because Windows 2000 and eventually like Windows 2003 was just super expensive, for, a high school kid. So, install Linux and Windows 2019 or 2020. I don't know if that's out yet, but install Windows and play around with it. And what is Sneakers? Oh my goodness. Sneakers is like the best hacker movie of all time. Take that back. The most realistic, like red team movie of all time. It's very true to kind of the what hackers do and kind of how they operate. And it includes social engineering and stuff like that. It's a phenomenal movie. It's kind of old, but I think it holds up. So I've been going for like an hour and 45 minutes. I'm going to take a quick bio break. And then I will return in just a few moments. So like a minute or two, but I'm going to put up a break slide, and let you all go refill your waters and whatnot. I'll be back in a couple of minutes. And we're back. I got to say, I got when I picked up the lights, I got a Stream Deck and, I love it. It's amazing. I have some streaming stuff associated with it, but I think I'm also going to use it for some flight sim stuff. Like it's just a neat little set of buttons, like programmable buttons, but it's phenomenal. Another big thing that the new CTF platform is going to change are things like that, where there's a configuration problem in the challenge that breaks the challenge. Like that's not great. That shouldn't be there. And of course, I can manually go in and fix that, which I did at the time. But it's just not a great practice. It's not a great experience for the people learning. And especially what I'm trying to build, what I'd like to get is something that can run pretty much automatically so that I could support multiple CTFs at a time or really whatever, with minimal impact from me, like minimal handholding from me, so that I can spend my time doing other stuff like interacting with the competitors or, helping people or whatever that is. So along with the engine is like new dev practices. So I'm building out a CI/CD pipeline for basically all of the challenges. So the challenges will get brought into Git, and then they'll run through tests. And so like every challenge will have its own Docker file created. It'll have its own like Terraform file created, and then it'll have a series of tests to make sure that it's, doing what it's supposed to and that it's solvable and that it's working. So that is a huge component. And I think a lot of like dev practices, CI/CD, QA stuff just isn't talked about enough. And like with the impact that they have on the quality of the thing that gets output, it's just such a huge deal. It's one of my number one recommendations coming out of an engagement is, there's like a bunch of stuff that you could do, but like really you should be baking this into your CI/CD. Like here are the scripts that we ran to find this and to exploit it. Bring these into your CI/CD process so that, this doesn't get reintroduced. you know, in the future. And you know, coming out of the build pipeline that this thing is fine. So. All right, let's move on. I think the next thing we have is scanning. So we'll have are they already running? I think they are already running. So wait. Let's bring these down, and we'll bring down the web ones as well, and actually see if the scanning ones are down, because I don't think they are. I think the DNS one's preventing them from going up. See, they're not coming up. Okay, so I'm just gonna I'm gonna comment out the DNS one, and I'll figure out what's going on there. So the way they're written right now is they depend on other containers, and I think they just point to the latest container from whoever made that. So like I'm just pointing to the bind container, and there might have been some update to that container that doesn't work. I assure you it worked during the CTF, but I can do the same challenge just on somebody else's box. It's not a big deal. Oh, you know what? I wonder if they didn't build because, yeah, damn it. I think these build much faster than the system ones, because the system ones were pulling like actual Ubuntu. Yeah, see, okay. The system ones were pulling like Ubuntu images, because I wanted them to be systems, you know, that once you got into them, they behaved like normal systems. Whereas like Alpine Linux doesn't necessarily have the same behaviors as like a Ubuntu box. So that's why those took so long. Okay, great. Oops. So we're going to less on scanning. Okay, so the very first one is a word from on high, which is a hint. And it says, a spy was able to infiltrate the village. They discovered a secret phrase and created a created a service that sends a code phrase. I don't know. A service that sends a code phrase when you connect to it, but we're having trouble finding it. Can you help? So it basically just gives us a host to scan. This is an Nmap challenge. And the big thing here is, again, we're not going to scan that host. We're going to scan my local host. The big thing here is that it wants you to use like -p- or it wants you to use -p1 to 65535 or whatever, because it's telling you a word from on high. Basically, it's saying a high port. People not used to running Nmap or masscan or something like that won't necessarily know that Nmap only runs by default on like the top 1,000 ports. So not just like 1 to 1,000, but you know, like just very common ports. If they don't know that, then they're going to struggle with this challenge a little bit, and then they're going to ask for help. And I'm going to be like, okay, well, let's work through this. Let's think about how Nmap works, and then they'll be able to practice using Nmap differently. This is going to have a lot more stuff on it than the other system had. The other system only had the challenge containers on it. So you'd see like 5553 or was it 5300 or whatever. You'd see whatever port this was, and then you'd see another port. But so we'll run this. This actually might take a second. It didn't. Okay, so we have a couple high ports. So 65480 is for a different challenge, so it's definitely not that guy. So we'll take a look at 6 653 or 65435. I'm not sure how your screen name is meant to be pronounced, but we'll call you Dr. Fact. I'm not sure what DRWBLK, how to pronounce that. But they say Mascan, then Nmap for detail, and I 100% agree with that. Mascan is extremely fast for just letting you know what ports are up, and then you can like Nmap with your NSEs, your Nmap scripting engines to get more detail on the boxes. 100%. So we're going to netcat to this port, 65435. And when we connect to it, we get the OK20 harmonica radio. And this is obviously, if you've played it, a reference to the horrible goose, where you you can actually pick up a harmonica and like honk through the harmonica, but you can also do that through the radio and like freak out people on the other end of the radio, which is great. Drew Black. Okay, well, that makes it super easy. So Drew Black, the Mascan, and then Nmap for detail suggestion. Okay, so the next one. Okay, what's in a name? So this is going to be the Nmap one. Or I'm sorry, the not the Nmap one, the DNS one. So there is a domain that somebody set up. Oh, DigiNinja set this up for people, but so let's read through this challenge. So our spy set up a Dropbox backdoor in the village's network, but we forget the IP. So a Dropbox is just like a computer that gets plugged in where it's not supposed to be plugged in to possibly give a backdoor. So modern day, a lot of people use Raspberry Pis, but Pony Express, if you're familiar with them, used to make, I don't think I have it near me. I think it might be in my closet, but they used to make these, they'd call them Pwn plugs, and they looked like things that you could, you just plug it into a power socket and it looked like a normal power socket. But it was like a mini computer. And so like Pwn plugs were great. And then, like I said, Raspberry Pis are the big ones now, but that's what a Dropbox is. So they dropped a Dropbox onto the network, but we don't know the IP. So he gave us the IP and port of their DNS server, though, as if that's supposed to help. Can you help us? Can you use this information to find the IP address of the Dropbox backdoor? So we have the DNS information. And so there's two ways we can get this. We can do what's called DNS brute forcing, where we basically just take a word list of potential host names and query for those host names over and over and over again until we get something back that's like, yes, we have a host called that. Here's the IP address. There is also a concept called zone transfers. And we've talked about this, I think, a few times in the streams before. But for those who weren't there, zone transfers is where you have multiple DNS servers. And really, you have one DNS server that should have only one that should have write capability to your DNS zone. And you want that server to be as protected as possible. So you tend to have that like in the very back depths of your network where really nothing can see it. You don't want it. You definitely don't want it exposed to the internet. And then you'll have like secondary and tertiary DNS servers that will need to have the same information that your primary DNS server has, but they're not necessarily write servers. So the way that those secondary and tertiary servers grab the DNS zone information from the primary is they initiate a zone transfer and just pulls all of the information about that zone from the primary server. You should only set it up so that explicitly only your replicates are allowed to initiate a zone transfer, but some people don't know to do that or don't think to do that, etc. So they kind of don't lock down the capability to set up zone transfers. And we're going to take advantage of that now. Now, the way you would do this challenge, if it were working, and again, I assure you that it was working. I assure you that it was working for the CTF events. People solved this challenge. But the way you would do it if it was working is you do a zone transfer against this server. But luckily, DigiNinja, thankfully, has set up a zone or a a server specifically set up to allow zone transfers for people to learn how it's supposed to work. So we are going to dig. Dig is just a DNS interface for Linux, similar to NSLOOKUP, but just a different utility. It does similar things. And we want to set up a zone transfer. We want to tell it that we want all records. We want every type of record to transfer. Now, you could set up a type A record or a type C record or something like that. We want all of them. So we do type AXFR. And then we're going to set it, and you point it at the server that you're going to query. Okay, so when you do a zone transfer, you tell it, this is the server that I want to zone transfer from. And if this were the challenge, we would tell it to zone transfer from this server, but that server's not up right now. So we're going to tell it to transfer from nsztm1.digi.ninja. And I hope that this is still up. They still have a blog about it. I'm hoping it's still up. And the zone, the DNS name, the zone that we want to transfer is zone transfer.me. Let's see if this works. I hope this works. Hey, there it is. So what we see here is we see basically every record that is available for that zone. This is extremely useful on a pen test for just learning all hosts that are available, right? We don't really have to do port scanning or like network scanning if we already know what all the hosts are. We can just scan those individual hosts rather than a whole subnet. And so we get things like MX records. So this is like the mail information. We get text records that can be for certificate verification or otherwise. We get some A records. We got some quad A records for IPv6. We got some other texts that are, this is actually the start. I believe this is the start of a CTF even. So there's like a full CTF around this DNS stuff. Some random attacks built in there in case like web crawlers are crawling through this, etc. So lots of different stuff in here. What you would have seen in the challenge is literally just a list of host names and then IP addresses. And one of the host names had flag in its host name. And so the flag that we're looking for is the IP address of that. I wish it was working. It's probably a small fix, but I don't want to spend 10, 15 minutes fixing it on the stream. But this is how you solve it, is literally it's a zone transfer. I would recommend, again, as I said when I was setting this challenge up earlier in the stream, it's surprising to me how few people have actually done a zone transfer. So I highly recommend, I'm going to put this in the chat actually. I highly recommend going to this blog and checking out the zone transfer that DigiNinja set up. Question from Drew Black is, what parameter goes after the @ and the one following? So great question. So the @ is what DNS server you're querying. Okay, so are you still seeing movement? Okay, yeah. I have a weird thing from YouTube saying that I'm not transmitting fast enough. Hopefully everybody can still hear me though. If you can't, let me know in the chat. So this is the DNS server that we're querying. So this is the zone server that has all of the authoritative information about the zone that we're interested in. And the parameter after it is the domain or the zone, but the domain that we're interested in. So you pull a single domain at a time. So if you're trying to grab multiple domains from this server, then you'll do them kind of one at a time. Yeah, everything's fine. Great. Okay. I don't know what the heck YouTube's saying then. Okay. Next up, cog in the machine. The village has begun organizing an anti-goose league. Oh no. There's reference to it on their web server, but our bots can't seem to find it. We need the secret phrase located on that page. Okay, so a few hints here. let's see what. 8888. Oh yeah, it says right there 8888. Okay, so we've got some web reconnaissance that we need to do. So we'll go to 270018888. Anybody know how to make a web page? All right, so the village is not off to a great start. But evidently there is some secret stuff that they already have on the page, but our bots, our goose bots, aren't able to find it. And that is telling. So there is a web technology that is specifically dedicated to messing with bots and instructing bots on how they should behave on a website. And that is the robots.txt. And so what this says is, what this does is basically, this is a series of disallows, explicit denies that you set up saying, okay, this user agent, and it's controlled by user agent, this user agent is not allowed to visit this page. Okay, and so you can set up for different bots. So you can say, hey, the Google bot user agent isn't allowed to access these sections of my site. The Baidu bot isn't allowed to access these sections of my site, etc. So you can set them up for different bots or different user agents. You can even say, Internet Explorer user agents aren't allowed to see this section of my site or vice versa. The problem is this is only for well-behaving clients. Okay, so people can change their user agent and still go. They can go directly, like it's not a firewall by any means. It's just instructing them like, hey, I'd prefer you not to go. And it's to prevent like Google or other web crawlers from putting your admin pages on their site and things like that. But it also helps recon in that we can see like what sections are considered potentially sensitive. So we see that there is an anti-gooseleague.html out there. And so we're going to go to it because, of course, we are. And we see that OK20 loose the goose is the flag for this particular challenge. All right. Now we have don't be a git. Yeah, the scanning and recon stuff has flown by super fast because it's a pretty short. It in the list of challenges is actually like the first list because they're the first set of challenges listed because they're pretty short and relatively easy. I guess if you've ran into this stuff before, if you haven't, then obviously it's not easy. But okay, so don't be a git. The league has published their website. It looks like the site used to have a secret phrase on it, but they've redacted it. Is there some way you can revert the site and see the code? Okay, so let's take a look. So we're going to port 65480. And we've got, they found somebody who can make a site. I mean, it's not an overly impressive site, but they made it. It looks like they've been hacked already. The goose represents anarchy and all that is wrong with this world. I like I said, I made all of these in like a week, so some of this I forget. But yeah, I put a lot of effort in all this. Okay, so if we take a look at the source, kind of scroll down towards the bottom, we see that there is a flag string, but it's been redacted. Oh no! So what do we do? Well, we can run Nmap, or we can run like Nikto, or Burp might be able to see this if you have active scanner on, or the spider or something. But there's like many different ways that you can look for this. This is not a fairly common thing, but this is definitely something I found in the wild. So this is a real thing. In fact, if you saw my Wild West Hackin' Fest, what was supposed to be San Diego, but was their first virtual one in March, I think March. I gave a talk on like web exploitation, and this attack came up. So if we take a look at this, Nmap will actually find this for us. So I did attack A to do its aggressive scan, but it'll do the default scripts and stuff associated with that, and that's why it's taken a minute to come back. And we'll see that it found a Git repository. So it found a .git file. And again, I wouldn't call this like super common in the wild. If you just start scanning like Nike.com and Amazon.com, you're not going to find you very likely will not find a .git file directory in their web files, but you will find it. I've found it on Bug Bounty. Like I've been paid out a Bug Bounty because of this. So you do find it. It's not everywhere, but it is in the wild. So what happens is these developers are deving their application. They're keeping it in Git for source control, which is great. And then they go to deploy it and they just deploy their working directory, or they git clone from the Git repository to the prod server, and don't clean anything up, don't have any scripts up, don't have like web application firewalls in the way to prevent accessing this, even if it does accidentally get deployed, whatever, like it's all over the place. So we have access to a .git folder, and actually like all Git repos have this. So if we go like, we go into this Git repo, we see a .git directory here. We also see the idea because I use PyCharm and stuff, but we see a .git, and that has all the metadata for the Git repository that it's part of, which is very useful to us. So we're going to wget, and we're not going to follow links, or we're not going to go up. We are going to turn links into hard files, and we're going to grab, we also want to, I think it's -r, HTTP 127.0.0.1, oops, those are not dots, 65480.git. Let's make a directory for this. cd127.git. And we see like all of these files, right? And this is all the metadata for the code repository. Now, if we go back here, since that has a .git directory in it, our Git command line knows that there was a Git repository here. It can access it. This is actually what the Git command interfaces with on your file system. So what we can do is we can start interacting with it as if it was a Git repository, as if it was ours. All of the code for the repository and all versioning is in that directory. So we're going to do something called git log. And just to make it a little easier to read, we're going to do pretty equals one line. And we actually see that we have a couple different commits here. And the current head, or where we are in the version control, is a commit that has the commit message of remove the flag. Very CTF contrived, but in the real world, what you'll actually see is something like, remove credentials, or security pass, or, something like that. When you see something like that, you don't want to revert to this one. You want to revert to that one, because that's the one where whatever mistake was made still exists in the code. You can also go back. You don't want to go too far back, because you might hit like an empty repository, and then you have to like kind of step forward. But you go to the one right here. So if we do git revert, let's bring that up, git revert, and then we just grab that, maybe I shouldn't have cleared it. We just grab this hash for the commit that we want to revert to, git revert. So we did a git revert, and if we less index.html, notice how that index.html is there. And if we actually scroll up, there was nothing in this directory before. And we look at index, and we see that the change was from peace and quiet to redacted. So this is how we get access to the previous content. And this is great when, like I said, when creds are hard-coded, or creds are commonly hard-coded in web apps, right? Like, so when you're dealing with databases, you have to have creds that allow the web app to connect to the database. You just generally don't check that php.conf file or db.conf file or whatever the file is that contains those creds. You usually don't check that into Git. And when you accidentally do, you have to remove it from Git. And actually, like, removing something, not just committing over it to like remove it from the current head, but actually like removing something from Git is a huge pain in the butt. So it's common that even if mistakes were made, those mistakes are still in the commit history and the revision history. So that is how we can interact with Git. So not just a way to kind of abuse Git files in web, but if you've never touched Git before, there's a couple extra commands that can kind of help you move beyond, you know, git add, git commit kind of stuff. I am not a Git master by any means. Like, you've seen pretty much the extent of my Git, but it's helpful to be at least maybe not fluent, but conversational in Git is very helpful. Okay, so that is, yeah, that's all the recon. Any questions, comments, concerns about recon as we move into web? No comments, questions, or concerns? Sounds good. Or maybe people are still just typing. Maybe there's so many questions, comments, and concerns that like people are writing dissertations. Less web. Okay. Oops. All right. So this one's going to have a lot going on in our web browser, and maybe even said there were, I think Tom Nom Nom said there's a way to go back and get past GitHub post. I'm not sure what specifically you're referring to, but if it's anything that's in the repo itself, that will get it, what we just did. If you're talking about like a wiki post, I'm not sure. And frankly, I don't actually use GitHub much anymore. I migrated to GitLab like a while ago. And so I'm just not, I don't deal with GitHub very much. The thing that I just showed will work in any Git at all. Like GitHub, GitLab, local Git, whatever. But yeah, I'm not sure what specifically they're referring to, though. I think I've heard of Tom Nom Nom, and I think their stuff has been pretty good in the past. So I don't know. If they posted a blog about it, I'd just try and recreate the blog and see. So this is going to be quite a bit of like web and some burp maybe. Burp will probably be like helpful in demonstrating some of this. Which burp is it? I think it's that one. Stream is getting hiccups. Why is that? There is skips. Why is that? I am getting some drop frames. Getting drop frames and I'm not sure why. Yeah, I'm not sure what the deal is. OBS is reporting some issues. But like it shouldn't be. My CPU's at 3% utilization. Memory is solid. Ethernet is fine. So my GPU is at 10%. Yeah, I don't know. And you guys, like, I'm looking at the preview for the stream, and you are like way behind. Well, I guess hopefully it's not that bad. Hopefully it's not that bad. I'll try and edit out a lot of this. YouTube's like in-app editor isn't super great, but I'll try and edit out a lot of this for the VOD. But I don't know, man. I guess we'll just keep going and hope that it does all right. Jesus, man. The drop frames is like way too much. I'm going to stop where I'm at. So hopefully, nope, we're dropping a shit ton of frames again. I don't know why. I don't know why this is. We may. Okay, we're going to try and. No, I'm getting like super wonky stuff.